Objective 3. Explain what it means for a statistic to be resistant. Which measure of central tendency is better to use, the mean or the median? Now it depends, and we're going to use the applet to answer parts A through E. So if we take a look at the applet, okay, we're going to click reset on the applet, and then we're going to create a data set of 6 observations such that the mean and the median are roughly 2. Okay, not exactly 2, but roughly 2. So in order to add a point, you would just click a point anywhere on there. If you want to remove the point, then you can just go ahead and it'll just go all the way off. Okay, so what we're going to do is we're going to select some points here. I'm going to select it around 2. Okay, and let's see here. Okay, so if you notice, here are the 6 observations that we've created, so 6. And the mean is roughly around 2, and the median is roughly around 2, and you can see where it is located. Okay, now for part B, what we want to be able to do, now that we've selected those points, now these points are rearranged again in different variations. Okay, and you can see again how, we have our 2 and 2.0. Okay, now we're going to click add a point and add a single observation near 9. How does this new value affect the mean, and how does this new value affect the median? So if we go ahead and click a point over here near 9. Okay, so let's just go ahead and see here. This is, let's say, near 9. Okay. The mean approximately increases by a value of 1. It has gone from 2 to 3. But the median didn't change that much. It changed a little bit. Okay, so that's what happens in that scenario. Okay, now, let's take a look at part C. Okay, so in part C, it says remove the single value near 9. That we added in part B, okay, by dragging it off the number line. Okay, so let's go ahead and do that. So we're going to take this number and we're going to drag it off the number line. Okay, now we're back to where we were originally. Okay, now we're going to click add a point. So we're going to click add a point here, and then we're going to add a single observation near 24. So let's go ahead and add a 24. Okay, so here's the single observation. Okay, now how does this new value affect the mean and the median? Okay, well, the mean increases by much more than the median does. So you can see here that the mean has increased a lot more because we picked that value over here. Okay, so let's take a look at part D. Okay, so part D is asking us to do the following. It's saying click reset and add a point near 0. So we're going to click reset and then add a point near 0. Okay, so let's move this to, let's see here, 0. Or in this case here, let's move this off and let's hit reset and add a point near 0. Okay, so there's a point near 0. And then we're going to add another point near 50. So we're going to add another point near 50. Okay, and then we're going to delete these points and create a symmetric data set of 6 observations such that the mean and the median are roughly 40. So we're going to go ahead and take that off. We're going to take this one off, and then we're going to go ahead and then select some points where it is, again, symmetric with 6 points. Okay, so we can see here that we've created 6 points, right? And the mean and the median are roughly around 40. Now, in part E, we want to add a single observation near 35. So we're going to go ahead and then add an observation near 35. Okay, how does this new value affect the mean? Okay, and the median? Okay, well, the mean decreases as the observation, you can see here, is moving towards 0, while the median stays the same. Now, if we grab this point with your cursor and drag it towards 0, okay, take a look at what happens with the mean. Okay, the mean keeps decreasing, right? So the mean is changing as we get towards 0, where the median has stayed the same. Okay, so now from the previous activity, you should have noticed that the value of the mean can be impacted by a single observation. So far, we've looked at two measures of central tendency, the mean and the median. Now we're going to use a statistical applet to see the relationship that exists between these two measures. Now, the data that I have on the screen currently right now, okay, is going to represent the sale price of a random sample of 12 homes sold in Seattle area. Now, if you look here, the mean is approximately 422,000 and the median is approximately 422,000. Now, what I'm going to do is add a point to the data set. Now, let's say some executive from Amazon buys a home that costs $4 million. Okay, so let's go ahead and add a point. We're going to call it 4 million. So 4, okay, and you can see here that the 4 million home had a significant impact on the value of the mean because now the mean has changed. But it really had no impact whatsoever on the median. So what we say based on this result is that the mean is not resistant, but the median is resistant. And what do I mean when I say resistant? Well, a numerical summary of data is said to be resistant if values that are extreme, very large or very small relative to the data do not have effect or do not affect its values substantially. So, based on activity 1, okay, and the video, we noticed that the median is not affected by extreme observations, but the mean is affected by extreme observations. So a numerical summary of data is said to be resistant if observations that are extreme, very large or small, relative to the data do not affect its value substantially. So the median is resistant, but the mean is not resistant. You may be asking yourself, why would I ever compute the mean? After all, the mean and median are close in value of symmetric data, and the median is the better measure of central tendency for skewed data. The reason we compute the mean is that much of statistical inference is based on the mean. Okay, next we have activity 2. And this activity, okay, is a relation among the mean, the median, and distribution shape. So we're going to use the following applet to answer parts A through C. So here is the applet, okay? And so what we want to do in part A is we want to move the cursor on the slider left so that the distribution is skewed left. What is the relation between the mean and the median? Okay, so if we move this slider to the left, okay, now what happens? Well, we can see that when we move it to the left that the mean is less than the median. So you can see what's happened when it's skewed left. Okay, now part B, move the cursor on the slider right so that the distribution is skewed right. So we're going to skew this to the right. Okay, now what is the relationship between the mean and the median? Well, now the mean here in blue is greater than the median. Okay, and so now in part C, we're going to move the cursor on the slider towards the middle. So we're going to go towards the middle. Okay, now when we go towards the middle, okay, until the distribution is symmetric. So what is the relationship between the mean and the median when it's symmetric? When it's symmetric is that the mean and the median are approximately equal. Okay, now the ideas explored in this activity are presented in Table 3 and Figure 3 below. Okay, a word of caution is in order. The relation between the mean, median, and skewness are guidelines. These guidelines tend to hold up well for continuous data, but when the data are discrete, the rules can be easily violated. So here's the relation among the mean, median, and distribution shape. The distribution shape is skewed left, symmetric, skewed right. Mean versus median. When it's skewed left, the mean is substantially smaller than the median, like down here in part A. Symmetric is when the mean is roughly equal to the median, and it's skewed right when the mean is substantially larger than the median. Okay, let's go ahead and take a look at an example here. Okay, now we're going to do this by hand, and then we're going to show how to do this by using StatCrunch. So it's important to understand how to do both. Now, obviously we have a lot of data in here. So in this example, we're describing the shape of the distribution. Now the data in table 4 down here represent the birth weights in pounds of 50 randomly sampled babies. For part A, we want to find the mean and the median birth weight. So if we wanted to find the mean, we would have to find the sum of all these values. So if we add up all these data values, we're going to get a total of 374.4. In part 2, we want to find the population mean. So we know that the value, there's 50 random sample babies, so n is equal to 40. So mu is going to equal the sum over the value of n. Well, that's going to equal 374.4 divided by 50, which is equal to 7.488. Rounding that to 2 decimal places, because our data was in 1 decimal place, is going to be then 7.49. So that's going to represent the population mean. Now, we want to then find the median. So if we want to find the median, then we have to take all these values and put them in ascending order. So 5.8 is the smallest observation going all the way to 9.4. Now, if we were doing this by hand, because there's an even amount of numbers, which is 50, then we need to take the value of n and divide it by 2. So 50 divided by 2 is equal to 25. And then we take that value of 50 divided by 2 and plus 1. So 25 plus 1 is equal to 26. So that means we're going to look at the 25th and 26th observation in our set. Well, that is 7.3 and 7.4. So let me go ahead and highlight this information. We know that the 25th position is 7.3, and we know that the 26th position is 7.4. So now we're going to, in order to find the median, we're going to add those together, 7.3 plus 7.4, divided by 2 to give us 7.35. This is how we would do this by hand. Now, obviously, we have a lot of data here, right? So we may want to use StatCrunch to be able to figure this part out. Okay, so what I'm going to do is I'm going to open this up in StatCrunch. So when I go to the data over here, I'm going to click this icon here, and then it's going to load everything in StatCrunch. Okay, so here is my data in StatCrunch. Okay, now what I want to do is I want to verify that we have the mean and the median. So what we were going to do is, in order to figure that out, we're going to go to Stat, we're going to go to Summary Stats, and then we're going to select Columns. Okay, we're going to select our birth weight. Okay, and then we're going to select N, we're going to select Mean, and then we're going to hold the Control button for that. And then let's go down a little further. So we have Mean, Median, and then we want to be able to also include the median here. So hold the Control button, you can see it's over here. Okay, so now let's go ahead and select Compute, and when we select Compute, you can see what we get. Okay, we have a summary of statistics. Okay, and so in this scenario, it gave us exactly what we did by hand. We can see that there's 50 observations. We see that the mean is 7.488, which we rounded to 7.49, and we can see that the median is 7.35. Okay, so now what we want to do is now we want to describe the shape of the distribution. So how are we going to be able to describe the shape of the distribution? Well, we're going to come back up here, okay, and what we're going to do is we're going to create a histogram. So remember how we create the histogram. We're going to select Graph, come down to Histogram, select Birth Weight, okay, and we can do the frequency, and that's fine. All right, and then we can start at the value, that's fine. We can keep that there. and then go ahead and select compute. Okay, so when we select compute, you can see that this looks like a bell-shaped scenario. So the distribution is roughly bell-shaped because it creates a bell-shaped situation. Now, whenever it's bell-shaped, now we need to, which measure of central tendency best describes the average birth rate? Now, because the mean and median are close to each other in the value because it's symmetric, we can then use the mean as the measure of central tendency in this scenario. So let's go back to the options. Okay, I'm going to go edit. I'm going to come down here, and then what I'm going to select now is I want the mean in green and I want the median in red. Okay, and then we're going to select compute so we can see what the graph looks like. So now you can see where the mean is located. Okay, and you can see here it's 7.488, and then there is the median, which is 7.35, and therefore we would use the mean as the measure of central tendency.